Hi, and welcome to my physics presentation. My name is Annika Courage, and today I'm going to be talking about electrostatic forces, repulsion, or attraction. Yay! Okay, so the scenario. The concept between electrostatic forces are between two particles or objects. They could be attracted or repelled. Like repels and opposites attract. So what's cool about this is in class we learned about electrostatic forces with tape and two balloons, basically by charging it and seeing what it does to the same object. I will use balloons and salt and pepper. My personal motivation and social cultural significance is that we're surrounded around electrostatic forces all the time. Spray painting, static electricity, printers, and even dust are considered electrostatic forces. Within this experiment, I hope to find the attraction or repulsion of balloons when I charge it by rubbing it on my head and seeing what it does to salt and pepper, since a balloon would have a negative charge if I rubbed it on my head, and the salt and pepper have a positive charge. So my overall hypothesis is that it would be attracted. And I want to see if I rub it for more seconds if it will be more attracted. The physics descriptions would be that I would use Coulomb's law for this. I need to find the force, and in order to do that, I need to find the two charges, multiply them, find the distance, and divide it, and use Coulomb's constant. Understanding the electric field and how it exerts forces onto other objects within the field is very important. Understanding electric potential and energy and voltage to move a unit of positive charge from a reference point to a specific point in an electric field is what I hope to find. So I coded it, and basically we did this in class on the week 1 homework as well, where we took two particles and we wanted to see if they attracted or repelled. So within the code, I described the Kc constant, I calculated the force on the net force between object 1 and object 2, and I rubbed it for 10 seconds and 30 seconds to found that there was more attraction when I rubbed it for 30 seconds. So the pepper was the red particle and the blue was the blue particle. And as you can see in the description, the force of 1 on 2 was positive and the force on 2 on 1 was negative, so it was attracted. And you can see through the orange arrows that they're going towards each other. And when I ran the code, the two objects ran towards each other, collided, and stuck together as they were attracted, just as I suspected. The class problem that I had for myself was if three charges are arranged on a straight horizontal line and are equally spaced as shown below, then I wanted to draw force diagrams to indicate this. So for 1, it had a negative Q, 2 and 3 had positive Q. And for charge 1, negative Q was attracted to both 2 and 3, but since 2 is closer in proximity, it was greater attracted. 2 is attracted to 1, but it repels from 3 because it's the same charge. And 3 would have the same idea. It would have a greater attraction to the negative Q and a greater repulsion to Q, because like repels like. We also found this in our formal lab 1 presentation, where we found the net force in the x direction due to an electric force between two balloons. And in that situation, I rubbed two balloons on the floor to see the repulsion of that. And to find that, we used Coulomb's law. We can similarly do that for an attraction, but for a repulsion, I found the mass, the acceleration, found force, and that was in coulombs. So that was negative 6.15 times 10 to the negative 9 coulombs. So that would make sense since they were repelled. But for this sense, they were attracted. So I wanted to throw that in just for an example. To investigate this, I wanted to ask some questions. What would happen if I rubbed a balloon on my head and I charged it and placed it above salt and pepper, since they had two opposite charges? Would the salt and pepper be attracted or repelled? And how is this connected to everyday life? I researched this and found a professor named Miss Holka on YouTube that completed this experiment and found that it was attracted. So electrostatic forces are important for technology, circuits, printing, painting, biomedical DNA, and even nanotechnology. To create this, I blew up a balloon and I put salt and pepper on a plate. I rubbed the balloon roughly on the floor for 10 seconds and for 30 seconds and found that when I rubbed it for 30 seconds, it was attracted, which is why I also coded it, because I wanted to indicate the animation of what it would look like, so there was a faster attraction. All I needed to do was blow up a latex balloon from the classroom and rub it on my head to charge it, which gave it a negative charge. Then I allowed the balloon to go over the salt and pepper, which had a positive charge, and it was attracted. Yes, the tape example from class was similar to this. Now the struggle was to track it. I tried to use Tracker initially to track the pieces of salt and pepper on the balloon, but the pieces were too small, so I animated it using code, using Coulomb's law as well. And thank you for watching so much.